This project addresses a common problem among elderly with memory disorders, which is the ability to navigate and recognize places. A seamless mobile navigation solution might support the elderly pedestrians, reinforcing social inclusion and self-esteem. In this project, vibrators are mounted on a belt to create a Vibrotactile display, which is used as a navigational aid. The benefits of using the tactile modality is that the system can be concealed under the user's clothing, hiding their inability to navigate as opposed to visual navigation aids. Furthermore, research has shown that the use of the tactile modality frees up cognitive resources and enables the user to use their sight and hearing to look out for traffic, talk, or enjoy the scenery. This project describes the development and initial examination of such a navigational aid. A prototype was developed and tested with elderly to examine the feasibility of using vibrotactile displays for them. Looking into previous efforts of vibrotactile navigational aids, these were found lacking in several areas. Therefore, this project examined how to improve in some of these areas. Several different approaches to designing vibrotactile signals and encoding distance information in them were examined through an experiment. Among other things, it was found that the gradient changes in amplitude are preferable, and a suitable method of encoding distance was identified. The developed signal was applied in a field study where an alternative to turn-by-turn navigation was examined. The alternative was based on showing directions to landmarks and letting the user figure out the details of getting there themselves. It was found that this alternative approach, which was dubbed landmark-to-landmark navigation, provided an improved sense of freedom but made the user more insecure. Landmark-to-landmark navigation is believed to improve the user's spatial understanding, which could be beneficial for the elderly with memory disorders, but this has not yet been examined. The project has paved the way for improvements in wearable vibrotactile navigation displays, which can be applied to elderly with memory disorders, but there is still work to be done. For example, the prototype needs to be completely integrated into a belt to allow examination of the social aspects of concealed navigational aids. Also, further work is required to examine the performance of vibrotactile belt displays when used by elderly with memory disorders, as opposed to the young and healthy subjects used in the field study of this project.